Alright, short little video here about ideal gases. We refer to them as ideal because they are very simple and that the forces between the gas molecules are so small that we can essentially assume that they are zero. So some parts about ideal gases, some assumptions that we can make so that we can solve some problems here. First and foremost, the molecules are perfectly elastic. And if you don't know what that means, go back and take a look at the video I made about matter. And how molecules or atoms are perfectly elastic, and you should know that from momentum and things like that. Also, molecules are spheres. We're going to consider them tiny little circles, three-dimensional circles, I guess. And also that molecules of one type of compound or one type of atom are identical. Also, there are no forces between the molecules, therefore they move with a constant velocity between their collisions. And molecules are very, very small, meaning that their total volume is much, much, much smaller than the actual volume of gas if you were able to condense it. Okay. Some things that you should know is that temperature of a gas is directly related to the kinetic energy of those molecules. Therefore, if the temperature increases, so does the speed of those particular molecules, because if you're increasing the kinetic energy, well, the mass of the molecules doesn't change. That would make them different types of molecules, so therefore the speed of those molecules would have to go up. Just keeping in mind that, kinetic energy is 1/2 mv squared. That stays the same, so that would have to go up, okay, if this value goes up. Okay. From your chemistry course, you should understand some basic connections between pressure and certain other things. Just right off the bat, though, reminder that pressure is basically defined as the force per unit area. And I've written a little side note here that said that force is really created by a molecule with a velocity that is changing directions. Well, okay, a change in direction, a velocity change, is known as an acceleration. So if you have an acceleration, then you would have to create a force. The molecule itself has mass, and it accelerates when it bounces off something, therefore creates a force. Okay, and as long as you have a force over a certain amount of area, you've got yourself a pressure. And then these are the basic relationships between pressure and volume. They're inverse. Pressure and temperature, and volume and temperature, and those things are all directly related. Okay?